All right. Volume of a sphere formula is 4/3 pi r cubed. You need to know that. Also, you need to know the surface area formula for a cube is 4 pi r squared. You need both of them because we're going to be using them both back and forth today. Okay, so the drama club makes a big ball from foam, that red thing there, to hang up above the stage for the play. They plan to cover the surface with metallic fabric. What's the minimum number of square meters that the club needs? So you're given the volume, you need to find the surface area. So here's the volume formula. Set the volume formula equal to the volume and work backwards. So multiply by 3/4 and divide by pi on each side, and r equals 0.75. That's what the radius is. Then you plug it into the surface area formula. Surface area is 4 pi r squared, so 4 pi times 0.75 squared. Do the math on your calculator, you get 7.1. So they need 7.1 square meters of this fabric to cover the ball. Easy peasy lemon squeezy. And you're going, what? Well, let's do this once, and we'll make it work. So let's say you have this much fabric, and you got to figure out what is the volume of the ball. Okay, you have that much fabric, you got to figure out what the volume of the ball is. So your surface area equals 4 pi r squared, right? This is your surface area. So 6 equals 4 pi r squared. How many different variables do I have in that problem? Just one, just the r, because pi is a number. It's 3.14159265, yeah. Okay, so divide by 4. So 1.5 equals pi r squared. Then divide by pi. What's 1.5 divided by pi?
0.48.
Something. If we take the square root of that, I bet r is something about 0.7, right? Really close to 0.7.
0.69.
Something. Really close to 0.7. Okay, now let's find the volume of the sphere. Okay, how big is the ball? Well, the radius is 0.7. So we go 4/3 pi r cubed. So 4/3 pi times 0.7 cubed. Is it like 1.43? Good enough. All right. What percentage of that total space inside that box does the ball take up? Okay, so you put a ball inside a box. How much percentage does that occupy? Well, what we have to do is find the volume of the ball and the volume of the box, and then divide them. Okay, that's all you have to do. But what's the problem? There's no numbers in here. We don't have a single dang number in that whole problem. Well, I know the radius of the sphere is r. What's the distance across here? Well, if we go this far to get r, and this far is also r, what's the length across? 2r. And it's a cube, so each dimension is 2r. So, the volume of the cube is whatever the side is cubed, or 2r cubed. 2 cubed is 8, r cubed is r cubed. The volume of the sphere is 4/3 pi r cubed. And that's just what it is. So what you have to do is to take the 4/3 pi r cubed and divide it by 8r cubed. What happens with the r cubes? They cancel. So you have to take on your calculator 4/3 times pi, hit equals, and then divide it by 8, hit equals. So it's 52.4% of the space in there is the sphere. The sphere takes up 52.4% of the cube. Okay. All right. What's the volume of a hemisphere? Well, a hemisphere is how much of a sphere? Half. So you had to take half of 4/3 pi r cubed. Well, what's half of 4/3? 2/3. So it's 2/3 pi r cubed. Well, if r is 4, it's 2/3 pi times 4 cubed. 2/3 times pi, did it again, pi times 4 cubed. 134.04. Do we need to do that again? No, you can do that. Okay. Instead of 4/3, it's 2/3 because it's half of a sphere. Okay. So let's say we got some corn silage and we throw it in our silo here. And we fill up the silo all the way up to the tippy top of the silo. What is the mass of that corn silage in that silo? Well, let's see. To figure it out, the volume of the bottom part is a what? Cylinder. Pi r squared h. The volume of the top part is a what? Hemisphere. 2/3 pi r cubed. So the volume of the bottom part is pi times, what's the radius? 1. And the height is 3. Volume of the top part is 2/3 pi times 1 cubed. So the top part is 3 times pi, which is 9.42. Volume of the bottom part is 2/3 of pi, which is 2.09. We add them together, it's 11.51. And then if we take that times 100 kilograms per cubic meter, because that's how many cubic meters we have, we get 1,151 kilograms of corn silage. Okay, well, guess what? I have one problem left. Then I'll come help you. All right. So if the height of the cylinder is equal to the diameter of the sphere, what's the volume of the space between the sphere and the cylinder? It's the same as the cube problem, right? Okay, except for we got to find the volume of the space in between. So should we add or subtract the two volumes? Subtract, because we're finding the difference of the two volumes. So we subtract. The radius is 12. So the volume of a sphere is 4/3 pi r cubed. The volume of a cylinder is pi r squared h. All right, so the sphere is 4/3 times pi times 12 cubed. Or 2304 pi. I could have multiplied it by pi, but didn't have to. This one, pi r squared. What's the height of the cylinder? If it takes 12 to get that from the middle to the top, what's the height? 24. So 12 times 24 times pi. Well, let's just go 12 times 24. Is 288 pi. So if we take 288 pi divided by minus 2304 pi minus 288 pi. 2304 minus 288 is 2016 pi, or a difference of 6,333. Okay. Oh, you know what I forgot? Forgot to square my 12. I was wondering why my answer was so big. Let's try that again. 12 squared times 24, which is 3456 pi. Now I subtract 2304 is 1152 pi, which is basically 3619. All right, so your assignment's out there. Get to work.